let's check. You say a bag contains a certain number of tennis balls that are of the same, that are the same in all aspects except in color. Okay? So there are 5 green. So we'll write to it, okay, we have 5 green. Okay? And then the rest are blue. So we'll say we have X blue balls. And then all in all, what is going to be our sample space is going to be X plus 5. That one. And then they say, who's this Nomi? Nomi picks a ball, observe the color, and does not put it back. So it's like not replacing it. Yes. And then he picks the second ball and observe the color. The probability that both balls that Naomi picks are green, it's 0. It's going to be 5 all over 18. No? They say determine the number of balls that are going to be in the bag. So we want to know the number of balls that are in the bag. Okay? So what's going to happen is that we can either pick a ball which is green. Maybe let's use different colors so that you'll see. So we can either pick a ball which is green. Okay? And then we can either pick, if we didn't pick a green ball, we can pick a blue one. Let's go to blue. So it's either we have green. If we don't have green, we're going to have blue. Let's take this blue. Okay? And then this is when we pick for the first time. Okay? Now, what is our sample space? Our sample space is X plus 5. Okay. And then our sample space is also going to be what to be X plus 5. It's still fine. Okay? So what is the probability that we'll get green? Green is going to be, how many greens are there? 5. It's 5. And then how many are blue? X. It's X. It's sharp. Okay? Yes. Now, if we get green, remember, now we are interested in this part only. Huh? Let's pick for the second time. If we're going to pick for the second time, if we started by picking green, we can either have another one. We can either have another one which is green again. If we don't have another one which is green, what are we going to have? We're going to have a blue one again.
Blue. Yeah. Yes.
And then singaba no blue. Okay, it's either we have green or we have what? We have blue. Now, what's going to happen then? These are the possible outcomes that we can have here. We can either have a green and a green. Right? And then how do we get
green? Yes.
We want the probability of this thing here. Remember, are we replacing or we are not replacing? That's very important. Okay? They say, which when picks a ball, observe the color and does not put back. If they don't put back, it means they are not replacing. You see this part? Okay? Yeah, it means they are not replacing. If you are not replacing, then sample space, it's going to be subtracted. You are going to subtract -1 with the sample space. Agree? You still have. Boom.
No, very 5. Mister.
Agree? We had X minus 5. Okay?
Yeah. X plus 5.
Yeah, we had X plus 5. And then we're going to remove 1 ball. We're going to remove 1 ball. So we're going to say X plus 5 minus 1 because we're removing 1 ball. So when we go to the second choice, the sample space H is going to change. So in our sample space, we're going to have X plus 4. And then here we're going to have what?
Oh, we keep it one Zankai Bisel.
Yeah, Zankai Bisel, yeah. And then when we go for the second time, remember, we chose 1 which is green. Green best na 5. Almost choose the 2. We no longer have green. How many do we have as green, man? I guess 31 green. Nice, he pick hill. How many greens are remaining now?
Oh, but 31. Yeah, but
31. That's not 5.
5.
That's not 5 green. 31. How many do we have when we choose for the second time?
4.
In a 4 green. So we'll still have 4 green. If blue, as next, did we choose any blue? We didn't choose any blue. Agree? We say if we choose green again. How many are still blue? It's still X again. Yeah. And then what is going to be our sample space? As I was saying, what is going to be the new sample space? The new sample space is going to be X plus 4, which is X plus 4.
Plus 4.
Yeah, and then probability of choosing green then is going to be 4 all over X plus 4. Probability of choosing blue is going to be X. Agree? We still have X, right? Yeah, and then Sizochi, this one multiplied by this one. Is those niggas are 5 multiplied by X plus 5. Okay? Multiplied by 4 all over X plus 4. Like this again. Lento le mpumi, but izosinikeza nayo basitshelile la ukuthi izosinikeza abantu. But it's going to, if they say he picks the second ball and observe, the probability that both balls that Ngomi picks are green, both of them are green and green, they say, which this is going to be 5 all over 18. Shoot it green and green. This one and this one, they're going to give me 5 all over what? All over 18. And then they want to know X. I'm sure X is going to be the number of blue balls. Okay? Or they say determine the total number of balls in the pack. So as long as we can get X, we'll get the total number of balls in the pack. Okay, and then from here, we can work. Let's work here. Agree is what this one multiplied by this one is about 20. All over. X multiplied by X, X squared.
X squared.
X multiplied by 4 is going to give us plus 4X. This one multiplied by this one, give 5X. Agree, these are two terms. Like when you multiply numerator and the numerator, you go to this one like you are foiling. And then you say this one multiplied by this one, and here's about plus 20. Which is going to be equal to 5 all over 18.
Oh, if you know 5, lago X plus 5 ngu 10. Go punch in calculate 10.
If you know lago X plus 5 being 10.
Yeah,
yeah, in my calculate, yeah.
Oh.
Okay, must kubeka kanje. I'm just funu X thina. Sizomthola kanjani X sizo cross multiply ngisho. Okay. How should we do it? Take this one to the other side.
5x squared 20x.
Okay, let's add these two. I agree these two are like terms.
Yeah.
Sizoba no 20 multiplied by 18. What is 20 multiplied by 18 there, girls? This one multiplied by this one, yeah?
360.
This is 360, which is going to be equal to 5 multiplied by x squared,
Yeah.
Plus 9x plus 20. I'm not going to multiply with 5. It's on 30 trial and divide by 5 both sides. Divide by 5, divide by 5. I can undo multiplication with division.
Yeah,
5 and 5, they're going to divide each other out. And if I say 360 divided by 5, what do I get?
72.
72, which is going to be equal to x squared, plus 9x, plus 20. Sifuna x thina ngisho. Sizothatha 72 lo samletha ngapha. One side saba no 0. So x squared, which is it's plus 9x ngisho. And then uzoba no minus 52, which is going to be 0. I mean, ngizosebenzisa i-Casio calculator manje. I can't factorize this.
It's easy to factorize it.
Table. And then I go to number 3. I'm lazy. I know we can factorize it, but I'm just lazy. Equals to 9 equals to minus 52. I'm just lazy. X is going to be equal to 4 again. Or X is going to be equal to what? To minus 13. Number of balls cannot be negative. Okay? So therefore, it means which X which is going to be equal to what? 4. So how many are blue? So how many are blue? Blue balls, there are 4. Yeah? So it means which you can come and say, okay, blue balls, there are 4. If blue balls are 4, you have 4 plus 5. What is the total number of balls that we have?
I must say,
yes.
What happened?
9.
Go down.
Yes. I agree with factorize this thing.
Oh, it
We
can
got
symbol
X.
space cannot be negative. Oh, thank
Number
you,
of
sir.
balls.
Yeah,
Number of
sample
balls can
space.
be negative, not sample space.
Number
Number of
number
balls.
of balls can
Yeah,
be
I'm asking you how
negative.
many balls do we have? You can't say we have
Oh.
negative 27 balls.
Okay, sure.
It can't be.
Okay, but, now we got the number of balls.
Okay, girls, I think show me your question. The What is your question? Nithetha kuphi Mpumi? Ikuphi?
Hayi, class working gileya ufuna leya yama outline.